Good evening, ladies and gentlemen.
So, we were given the values for all the ends, and then also we were giving their averages for all the ends. And these represent students that are at risk, and these are the test scores they took in the certain groups. N1 was for a group that wasn't so smart, N2 was a group that thought they weren't smart, and N3 was a group of underachievers. We were given the SS error of 749.85, but in order to figure out the rest, we needed the SSB. So in order to solve for the SSB, we used the equation of, we're wrong right here, but it's okay. This should be SSB. The summation of n times the x average over x double bar squared. But we don't know what x double bar is, so we're going to use the next equation, which we're going to call the x double bar equation, to find x double bar. And what that is the summation of n times the average all added up divided by total number of n's, which ended up being 90. So the value for x double bar that I got was 10.67. So once we inserted that into the SSB equation, we had an SSB of the group of 79.302. And through that, we went ahead and used our degrees of freedom for the group at 2, and then the error at 87, and then we calculated the mean square, which ended up giving us 39.657, and for the group, and for the error, 8.619. And through that, we ended up finding that the F value was at 4.06. And the question the book asks is it relevant if we use a 5% or a 1%? So we calculated the F table. At 5%, we get 3.101296. But at 1% we get 4.8577. This means that if we calculated it at 5% and used that value, that we would discard the hypothesis saying that there is no difference between the different groups. But at 1%, we're going to say that there is a difference between the different groups, and the different groups being people who aren't smart, the people who don't think they're smart, and the people who just don't work hard. In summation, it does matter whether you use 5% or 1%, and we would use 5% and say there's no difference between them.